ओके, लेट्स स्टार्ट द लेक्चर अगेन। सो हम देख रहे थे कि अगर कोई भी इफ यू टेक फॉर एनी अल्फा बीटा इन एस वेयर एस इज टी एक्स, फॉर एनी alpha beta belongs to S, which is tx, and x in x, we have we have we have this x alpha beta xst, like that. It's equal to x alpha by definition of composition. And one more thing, x times the identity. Okay, that's obviously because you are defining by action by you are taking the image of x under this map, identity map. This is equal to x of this identity, that's equal to x itself. So therefore it is a right test system. Therefore this x is a right as x is a right as system. X is a right as system. So next we define the Cartesian product of the systems. तो एक और बात जो मैं यहाँ पर बताना चाहूँगा, अगर सपोज t है सब मोनाइट टी एक्स का, ओके, फुल ट्रांसफॉर्मेशन सेमी ग्रुप का. सो if x alpha is equal to x beta for all x in x, where alpha and beta is in t, their transformation, then it always implies that this alpha is equal to beta, because they are equal maps, and action is defined like this. It is x, this x alpha is the image of x under alpha, x beta is the image of x under beta. But it's not true always. अगर t कोई right s system होगा, वो x alpha x beta के बराबर. Now t is not the transformation semi group. T is any monad which is right s system, which is this x is right t system. Okay, x is right t system. X is right t system. So, and in this x alpha equal to x beta for all x in x, it does not imply that this alpha is equal to beta. It doesn't imply alpha equal to beta. But for this particular, if t is a submonad of the transformation monad, if in this case, if we take this as a monad and this x as a right t system, okay, right t system, so then x alpha equals to x beta for all x in x implies that alpha is equal to beta always. But in general it's not true. And there is an exercise example इसने दी है, वो exercise है इसी चैप्टर के 8th चैप्टर के लास्ट में exercise है. That's exercise number 1. उसको आप देखिए, exercise 1 इसकी है ये. वहाँ पर इसने इसको explain किया, वहाँ पर actually relation इसने define की, उसी से इसने इसको explain कर दिया है. So next we define the Cartesian product of two systems. So suppose we have a left s system and a right t system. So suppose x is a left s system and y is a right t system. Define action on x cross y by action इस पर define करेंगे, define both right and left action by s times x y. Define action on this by this thing sxy, and we define also the right action with the help of t. This is equal to x y t for all x y belongs to x cross y, s belongs to s, t belongs to t. And you can see this is well defined because because our x is left test system, so Sx is well defined. Sx is an element of x. Okay, and this y is the right t system, so that means yt belongs to y. So this pair, it is in x cross y, and this pair, it is also in x cross y. So both are their actions actually. First is the left, it's a left action on x cross y, so it's a map from s cross x cross y to x cross y. तो यहाँ पर जो आपका x है वो x cross y है. इसी तरह से जो सेकंड एक्शन आपने डिफाइन किया है राइट एक्शन, so it's a map from x cross y cross t to x cross y. Okay, and we will see that these are actually actions. These are actually, this is left action, this is right action, this is left. We will see that x cross y is a left S system and it's also a right T system. So then for all S1, S2, S, we have S1, S2 of xy. By definition of action, it's equal to S1, S2, x, y, but this x is a left S system. It's S1, S2. Okay, it's S1, S2, x, y. Now this one, it's equal to S1 times, by again definition of action, जो आपने action define किया है. So this is equal to, it's S1, S2. Okay, S1, S2 here. So it's equal to S1 times S2 of x, y. And the identity x, y, by definition of action, it's equal to 1x, y, but x is a left S system, it's x, y. This is true for all x, y belongs to x cross y. So next we check the right system property, right T system property, right T system property. So again for all T1, T2 in T and xy belongs to x cross y, we have xy T1, T2. You can see this is equal to xy T1, then T2. This you can easily verify this. And xy with identity, this is equal to xy. This is very easy. So we check it is actually a ST by system. Finally, for S belongs to S, T belongs to T, and the pair xy belongs to x cross y, we have this S xy t. This we'll show that this is equal to S xy t. Okay, this is equal to S. Now let's look at this. It's by definition it's x y t, and again by definition this is equal to sx yt. अब मैं t को बाहर निकाल सकता हूँ again by the definition of action actually. So this is equal to sx yt. अब हम s को बाहर निकालेंगे, t तो ऑलरेडी आपने बाहर निकाला ही, इट्स s. अब पहले s अप्लाई होगा फिर t अप्लाई होगा, t आपने पहले ही बाहर निकाला. So therefore x cross y is an ST by system.